Statistically speaking, a large space rock will strike Earth one day. If humans are still around when the impact occurs, we may witness the destruction of a city, a nation, or a significant portion of terrestrial life. A mission approved by the European Space Agency, ESA, this week is part of the first step in building a planetary defense system to ensure we're ready if and when an asteroid comes knocking. The Hera mission is a companion to NASA's Double Asteroid Redirection Test, DART, mission, scheduled to launch in July 2021. The spacecraft will travel for more than a year to the double asteroid Didymos, a 2,560-foot diameter main body orbited by a 525-foot satellite moonlet called Didymos B or Didymoon. DART will slam into the Didymoon, altering the object's speed by a fraction of 1%. Scientists project the impact will be enough to change its orbit by several minutes. The test mission will help scientists prepare in case humanity ever needs to alter the course of a real asteroid to prevent it from hitting Earth. While observations from Earth can somewhat assess DART's success at altering Didymoon's orbit, a closer vantage point will give a much more detailed picture. That's where the Hera mission comes in. Mike Wall at space.com reports the probe will likely launch in 2023 or 2024, taking 2 years to reach the asteroid. Upon arrival, Hera will circle Didymoon, mapping its surface, measuring its mass and determining the effect of DART on its orbit. In addition, 2 briefcase-sized CubeSats will land and collect data on the asteroid's composition and history. Simulations of asteroid deflection by impact are only as good as the knowledge we put into them. With Hera and DART, we have the unique opportunity to test our simulations and feed them with new knowledge about the asteroid's response on impact, Kai Wuneman, who studies meteorite impacts and planetary physics at Freie Universität Berlin, said at the conference, reports Space Daily. Both missions are part of the Multi-Agency Asteroid Impact and Deflection Assessment, AIDA. Originally, Wall reports, the ESA signed onto the AIDA collaboration to build a spacecraft for their asteroid impact mission, AIM, scheduled to launch this year, well before DART. The early launch would have allowed AIM to arrive at Didymos B to observe the collision in real time. However, in 2016 Germany pulled funding from its portion of the AIM project, leading the ESA to cancel the mission. NASA, in the meantime, soldiered on with DART, deciding to assess its impact as best it could with terrestrial telescopes. Last year, the ESA proposed the Hera mission to replace AIM and help collect as much data as possible from the asteroid impact. Earlier this month, in anticipation of an ESA budget meeting that greenlights new projects every 3 years, scientists around the world began a campaign called Support Hera. At a press conference in Berlin last month, organizers released an open letter supporting the $320 million mission signed by 1,200 scientists. Patrick Michel, the lead scientist for the Hera mission, told Megan Gannon at Space.com that the mission was necessary to get the maximum data from DART. "You need a detective that goes to the crime scene to understand carefully what happened," he said. Space agencies have recognized the threat from asteroids for decades. In 1967, a group of MIT students designed a plan to detonate a nuclear bomb near an asteroid to prevent a collision with Earth. Others have suggested building a gravity tractor, a spacecraft that would slowly pull an asteroid off its trajectory over years or decades. But it wasn't until 2016 that NASA established the Planetary Defense Coordination Office. AIDA is the first attempt to test the defense techniques. The probability of an asteroid impact is low, but the consequences are high, Michel tells Gannon. This is why it's relevant to take care of it. Moreover, we have the tools. We can't lose more time. We have studied this for 15 years, so what are we going to do if it doesn't happen this time? Do more paperwork? Spend more money? In a press release from the Europlanet Society, Michel explains that what we know about these space rocks is very limited. For instance, when the Japanese probe Hayabusa 2 dropped a projectile on the asteroid Ryugu earlier this year, it made a crater much larger than expected, suggesting the asteroid is very low density and primarily made of loose rock and dust held together by gravity. Such findings can completely alter how researchers approach asteroids that threaten Earth, and scientists hope Hera will help close the knowledge gap. Ultimately, very little is known about the behavior of these small bodies during impacts, and this could have big consequences for planetary defense, Michel says.